Hello, everybody, and welcome to Unit 14. We're going to be covering deserts, right? We saved the best for last. This is an important unit for anybody taking this class in Arizona, which I believe is all of you. So hopefully, learn something about the state that we live in. So, Section 1. What is a desert? First things first, right? Desert is an arid place. Less than 25 centimeters of rain per year. I say rain, could be any kind of precipitation, right? Snow or rain or hail or anything, water falling from the sky. Now, what a desert does not have to be is hot, all right? We live in a hot desert, but it doesn't necessarily need to be high temperature. There are plenty of cold deserts. Actually, the biggest deserts on Earth are colder deserts. Yeah. So just because ours is hot doesn't mean that they are all hot. The rainfall that does happen tends to be sporadic, and when it does come, it comes as a big storm, very, very intense. If you lived in Arizona for some time, hopefully this should sound familiar. The torrents of rain. Uh, Erosion by water is common for most of these deserts, most of them. And believe it or not, actually make up 25% of the world's total land area. Of course, these are areas where there tends to be a little less population, but tons of area, a lot of the world. Now, let's just look briefly. Measurements for rainfall in Maricopa, yeah, county we live in. So, if we look at the summer months specifically, right, might be most in need of rain. You look at the difference, right? These are our figures from 2020. These are our figures, the average, only since 2007, so not going way back, just recent history. You look down 2 inches last year, the month of July, inch and a half for August, almost an inch in September. Yeah, this is enough to qualify for a drought, right? This is a, I mean, average 12-month rainfall since 2007 is 9 inches. For the last 12 months, we have gotten almost 2.5 inches worth of rain. Massive amount down. Now, hopefully, you have been paying attention so far and you know what it is that might be driving this change in the climate. That is all I'm going to say. These are the facts. I will leave the rest to you guys. What are the 5 types of deserts we're going to consider? So, variables here, we're looking at location on the globe and air circulation patterns. We have subtropical deserts and polar deserts, which we're going to sort of talk about together in this first section. We're going to have continental interior deserts, rain shadow deserts, and coastal deserts. So first, subtropical and polar deserts. We're going to consider these together because they have a similar driving force, which is descending cool, dry air from the upper atmosphere. And if you have dry air in the upper atmosphere, everything below it is going to be dry. As far as the actual physics involved, what you need to remember is that cool air doesn't hold as much water as hot air. Subtropical deserts tend to be located about 30 degrees north or south of the equator. 30 degrees north or south latitudes. Go into more detail about what latitude is in a minute. Polar deserts, just like in the name, tend to be located in polar regions. So, probably a good time, although we're at the end of the course, to cover this. This is the equator, and these are our lines of latitude going north, south, up and down the Earth. These are all equally spaced, going north to south, but the smaller circles do get smaller as you approach the poles when it comes to latitude. These are lines of longitude. They go from what's called the prime meridian, and you count going east-west. These are all about the same length, going all the way around the globe. The best way to remember this, I think, is with a ladder. So latitude is like climbing the rungs on the ladder, like this, and the longitude is the long side of the ladder, going all the way, this long side here. Just an easy way to remember it. So there are a couple of certain latitudes which are especially important. Right? Here is our equator, important because it divides the Earth into north and south. We also have Tropic of Cancer in the north, Tropic of Capricorn in the south. I'll talk a little bit more about what these mean exactly on the next page. We have our Arctic Circle and our Antarctic Circle. So what is special about these lines here other than the equator, which we all know and love. So the Arctic Circle marks the southern limit of the area up at the pole, which has at least one day out of the year, which is total sunlight or total darkness. Right? Northern hemisphere, the Arctic Circle, is going to be total daylight during the summer solstice and total darkness during the winter solstice. So everything which is more north of that Arctic Circle, right, that line on the map here, is going to have at least one day out of the year which is either complete sun or complete dark. And as you get closer to the pole, this gets more extreme, to the point where if you're at the North Pole, you've got 6 months of sun, 6 months of no sun. And the Antarctic Circle is exactly the opposite, but in the southern hemisphere. So they have total daylight for the winter solstice in December, total darkness for the summer solstice in June. Right? Just exactly the opposite of what's going on in the north. Now, the Tropic of Cancer is the one north of the equator, is the most northerly latitude where you can have the sun directly overhead during the solstice. Right? Northern hemisphere is going to be the summer solstice, where you have the sun directly overhead. Equator, we all know, love it, divides Earth into northern and southern hemispheres. Tropic of Capricorn in the south, notice same amount south as north. This is our most southerly circle of latitude where you can have a sun which is directly overhead. In this case, it's going to be for the winter solstice, again, December. Why am I telling you all of this? Because it's good to know. That's why. So this diagram, I'm not expecting any student to completely understand and know and remember what is going on here. What I do need you to know and to look at is the broad patterns, right? So we get deserts here, right, at 30 degrees. We get deserts here at the poles. And what do these two have in common? What do you see in common for those two? So, common theme there. Descending, cool, dry air. Right? The equator is going to have warm, hot air. Comes up. It has no direction to go but north or south. Goes north until it gets to here, and then it descends. And this descending, cool, dry air is what causes deserts here. And it is the same factor up at the poles. Right? This descending, cool, dry air is what causes these deserts. Subtropical deserts and your polar deserts. So if we look at the map here, it should be apparent. Right? We have one line of deserts going here, one line going down here, about 30 degrees north of the equator, right, including us, and south of the equator, as well as deserts at the poles. Right? And even though these don't look like deserts per se, you say, oh, there's a lot of ice there, must be a lot of water. Precipitation is the main factor, not temperature. Please remember this. Yes, in years else. So going ahead and stop here, we'll pause. Stick around for the next section. We'll do the other part covering these sorts of deserts.